Okay, so if you haven't already printed this sheet out, go ahead and do that because you're going to want one for your own. I'm going to fill it in. Normally I would write this on the board, but we will fill this in and you will have this summary sheet, which is a good tool for studying. And we're going to summarize what we've gone through so far, which includes glycolysis, I can probably go bigger than that. And pyruvate oxidation, and the Krebs cycle, which is also called the citric acid cycle. And it's also called TCA cycle. And let's see if I can get that to go up a little bit. Okay, so the location is always going to be important. The location for glycolysis. Glycolysis is a very old series of biochemical pathways, and so cytosol, you don't need any special organelle for those reactions to occur. The reactants of glycolysis, you're going to start with 1-glucose typically, and that is your C6H12O6, more or less. And you also are going to have some other reactants, but let's think about products. 1-glucose is broken in half, and you end up with 2-pyruvate, sometimes called pyruvic acid. You also are going to end with, if you recall, you had a net production of 2 ATP. And you had a production of 2 NADHs. So if you forgot, you can go back and look at the long version, but you'll see that those molecules are in there. Well, the 1-glucose is broken in half, and that makes the 2 pyruvates. But for these other products, we need to list some reactants that correlate. So for 2 ATPs, that came from 2 ADPs plus 2 phosphates that were loose. Sometimes that's called inorganic phosphate, P with a subscript I. And for the NADHs, you may remember that 2 NAD pluses, they pick up the electrons and an extra hydrogen to become the 2 NADHs. So that gives us a nice reactant and product accounting for the first stage of cellular respiration. Now the second stage of cellular respiration is pyruvate oxidation. That occurs in eukaryotes. It occurs in the mitochondrial matrix, which you may recall is that middle space, the very innermost space of the mitochondrion. In prokaryotes, it just happens at the membrane, at the cytoplasmic membrane or the plasma membrane. Now, remember that the products, the carbon compound products of glycolysis, are going to carry on and become the reactants for pyruvate oxidation. So the 2-pyruvate will become reactants. And by the end of pyruvate oxidation, those 2 pyruvates are 2 acetyl-CoAs and remember, acetyl-CoA is just a 2-carbon molecule, so we have to account for the missing carbons, and they have been released as CO2. Okay, so that accounts for all your carbon compounds in any case. Now, also, you may recall that there were also two NADHs, two NADHs that were made. And if there were two NADHs made, then there must have been two NAD pluses that were reactants. So those picked up some electrons and became NADH. And then in the Krebs cycle, you're going to also have, I'm just going to copy this, your location is the same as pyruvate oxidation. And you're going to start from those two acetyl-CoA. And ultimately, through decarboxylation reactions, all of those carbons are going to be converted to CO2. So this is really important. By the end of the Krebs cycle, all 6 carbons of your original glucose have now been changed to CO2 in the form of CO2. Now, you may remember when you come into the Krebs cycle, there is a molecule called oxaloacetate. And when you, so you get the same errors that I would make in lecture. You still get them online. And then, but 2-oxaloacetate also are produced by the end. So that kind of, if you have the same thing on both sides of the equation, it sort of, you can sort of cancel that out. But you need to know what oxaloacetate is. It's the molecule that originally binds to the acetyl-CoA in the first step of the Krebs cycle. And then it's regenerated in the last step. All right, then you have 6, you may remember 3 NADHs that are made, but you have to multiply that times 2, so 6 NADHs are made, 2 FADH2, I don't know why that's doing that. And then, sort of indirectly, 2 ATPs. Via a GTP intermediate. So if there were 6 NADHs, then you must have started with 6 NAD pluses. So I'll just make this balance. And if there were 2 FADH2s, there must have been 2 FADs to start with. And if there were 2 ATPs, then there must have been 2 ADPs plus 2 inorganic phosphate. So at this point, we have filled in the better part of this chart. But we do have this last part, and I haven't lectured on that yet, so you're going to put this to the side, and then we're going to finish the lecture on the very last stage of cellular respiration, and then we'll fill this in. Because one thing you'll notice is, so far, we've completely oxidized our glucose to 6 CO2, and we only have a few ATPs to show for it. And I told you we were going to make maybe 34 ATPs from one glucose, from the energy of one glucose. So most of the ATP production, I think you can tell, is going to come from this very last stage.